Hey guys, welcome to another episode of Vaping with Vape Apes. I'm Cam. Today we're going to demystify all the BS surrounding mechanical mods. I'm going to explain them start to finish in a language you can understand. We're going to dive in close. We're going to do this in one take. No editing, no BS. It's going to be simple language. Everybody's going to get it, okay? There won't be any confusion by the end of this, I hope. Okay guys, so here we are up close. I've drawn a little diagram. This is, it's so simple. Anybody should understand this. In order for this is our addy up here, okay? In order for that little wire to heat up, we have to pass power through it. The only reason it heats up is because we put so much power through a very tiny little wire that it gets hot. So, and that's how we vape, right? Okay, so every mechanical mod is basically the same. Either they make a connection to the positive or make a connection to the negative to complete a circuit so that will heat up, so that power will pass through it. Okay, so I'll give you a bottom button here. That's what we're going to base all this on. Now, a side button usually makes connection to the negative, not the positive side of the battery. Okay, so here we are. We have our top of our mod here, and we have our 510 connection. Now, a 510 connection is a very, very simple connection. That little screw on the inside is your positive. Where it screws into on the outside is the negative. And if you look inside there, it's always got that center post, which is the positive post. Okay, it's just that easy. So basically your entire mod acts as the negative connection. Okay, so all the outside is your negative. All of it is negative. Okay, because it's DC, we don't get electrocuted. Okay, but it's very simple. So we have our mod sitting on top, okay, and we're just going to talk about this, okay. So right here, this is a Chi-Yu mod, okay. This has no floating 510 connection or anything. Everything is adjustable. So what you need to make sure is that your positive connection makes contact when you put your battery in. That's why they have this pin. Now, the big part moves the actual 510 in there in and out so that it can make connection with your atomizer. So when you put this in, you back this out, you put this in, you tighten the big thing down till it makes connection with that, and that allows you to have some adjustability so that your atomizer will sit flat. On a floating one, you just screw it in and that backs out automatically to adjust it, okay? But on this one, you have to adjust it. So you tighten it up till after you put this in and that makes connection. Now, the other part you have to make connection with is the battery. Because you adjust this in and out, right, that 510 connection, it moves this side, okay? So it has the center pin here, this little centerpiece that moves in and out as well to make connection with the top of the battery. So after you screw that in and you get your 510 sitting and your addy sitting flush on the top, you start backing this out. You put your battery in, you screw this on, you give it a shake. If it rattles, it's not making perfect connection, also known as battery rattle. So you continue to move this out until this screws in nice and flush or very close to flush to make connection with the top of the battery, right through this little dinky pin here, okay? I mean, it's really simple. That's why these are set up that way. That does nothing more than put positive power through to that center brass pin, okay? So now that you have the top in there and we have connection to the top of the battery, this is the positive side of the battery, how do we make a circuit? So we have our addy, which now has connection up the positive side to the positive pin in your addy build, right? Now you connect a small wire from the positive pin to the negative pin, which is the rest of this, right? So, and then in the bottom, to make that connection to the negative side, we have this. We have a pin. So when you put your battery on here, the negative, you notice it sits on top of that. It doesn't drop down onto that pin. You keep that pin nice and tight, right? And then when you, if I could get this unscrewed, sorry. So this is in there nice and tight. Remember, if this pin backs off, it'll make negative connection without you pushing the button, and it'll always have your addy on until your addy burns out or your battery explodes. So always make sure, I always put just a little bit of blue Loctite on there, because you know, once you get the bottom pin set up, you shouldn't really have to move it, right? So this sits on top of the little silver ring on the outside, so that pin doesn't make connection. When you push the button, dink, it just moves it up just enough to make connection with the bottom of the battery, thus completing the circuit. So once that pin moves north, it touches the bottom of the battery. The negative connection is made everywhere, including the screw, and it goes up the side to the negative, comes around, and the positive pin is already connected. This lights up, and you have your connection. It's that simple. There is zero circuitry in this. None. There is a circuit that you manually connect by pushing that button up. So provided you have the top pin making connection to the top of the battery, if that's making connection to the top of the battery, and the bottom pin is making connection to the bottom of the battery, and both these are screwed in and your addy's on top, then you're gonna have a connection. And that coil that you built and put in there will light up. If all this is done and that coil doesn't light up, your coil is not connected to both the positive and the negative. It is that simple. Now people say, well, why do they use mechanical mods when they do these big, huge cloud vapors and stuff like that? Well, the reason is because no longer does this control, or the circuitry inside there, control how much power goes to your addy. What controls the power going to your addy is this build here. The lower the ohm rating, the higher the wattage to heat this, and the hotter this glows. So ohm rating is nothing but the amount of resistance. So if you have a lower resistance, more power flows from this battery to that. Now, you have to be careful, because if you build it too low, this battery will just explode, because it's only rated for 35 amps, right? So there has to be an amp thing, right? So now you want to use your Ohm's Law calculator when building this, and you never want to build a coil on an addy without knowing the ohms, okay? So it's very, very simple, guys. Okay, your Ohm's Law calculator. I have one on my phone, and it's so easy. It's crazy. People say, oh, that looks so complicated. But it's simple. You build your coil, okay? Then you enter in your numbers. You have to enter in 2 of these. So we don't know what the wattage is, because that's variable, and we don't know what the amperage is. What we do control is the voltage of the battery, which is 4.2 if it's fully charged, so that's what you always use as a basis, because this will never be more than 4.2 volts. I don't care how much you charge it, it'll be 4.2 volts. The circuitry in the battery, if it's a protected battery, will prevent it from producing any more power than 4.2 volts. So you always use that in your voltage. So we just enter that in there, 4.2. That is a constant number in that voltage, okay? Constant, always 4.2 volts, okay? Then, once you figure out what your ohms are, so you slap your addy on here, okay? And we test the ohms. We kick that on, okay? 1.06, that's the ohms, 1.05. Now that we have that number, we enter it into the resistance, the ohms, 1.05, okay? Then we calculate. So with this build, with that amount of ohms, this battery will put out 16.8 watts and 4 amps. Now I can go all the way to 35 amps with this battery, it says. I suggest that you stay at least 10% under the rated amperage, if not 20%. So 10% of 35 amps is 3.5 amps. This battery should never, ever, 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 ever have more than 32.5 amps going through it. Even at 32.5 amps, if it's a constant draw, this battery will start to warm up and you could be talking failure of battery. So, what do we need to get 32.5 amps? Well, you'll notice that we set the voltage at the standard 4.2 volts. Then as we lower the resistance, as it goes down, as we lower the resistance to 0.14, say, and we calculate that, look, now we're pushing 126 watts and 30 amps. This is about as close as I'd go with this battery. 5 amps less than what it's rated to. So you could build with less wire, thicker wire in this. The thicker the wire and the less of it there is, the less resistance there is. So you use a thicker wire like a 22 gauge, a couple 3 wraps, this would be down in the 0.1 something mark. Try and get it to that 0.14 mark and you'll be pulling 126 watts. So quite simply, it's how you build this that determines the wattage and the voltage, or the wattage and the amperage that this battery produces. Okay, it's very simple. Okay, do we all understand that? All we're doing is making a circuit. If you have any questions, please rate, comment, subscribe, do all that. Okay, and I'll be sure to answer your questions as you go. That's what I wanted to explain. And simple battery safety says don't get too close to this 35 amps. You know, always use a high amperage battery, a high drain, high amperage battery for battery safety. And always, always stay well underneath the rated amperage. That's my laws and what I do, okay? So thanks for tuning in to Vaping with Vape Apes, and I hope to see you next time. Until I do, remember, vaping kicks ass, and we'll see you again.